And actually, Maddie forgot to mention one very important thing, and that's MotherDuck or DuckDB community. Yeah, I joined the community, their Slack, like more than half a year ago, and the support there is basically incredible. Like some of my questions were responded in tens of minutes by CEO of MotherDuck. Yeah, that's really unusual. Uh, yeah. You underutilized him. That's yeah, I can imagine. So I really recommend to join the community. They will help you just like they helped me to build a concrete integration of not only MotherDuck but also DuckDB with GoodData. Yeah, and that's what my presentation will be about. But before we start, recently OpenAI released GPT-4o model. So I was thinking about to create a picture, funny picture, combining GoodData, MotherDuck, and DuckDB. And actually it didn't work, as you can see. There is no MotherDuck because GPT-4o training data sets do not contain MotherDuck yet. Yeah, so that's a pity. So my entry point here in this presentation is this claim. Yeah, so you should wake up from Stockholm syndrome. You should no longer accept spinning wheels in your BI tools. It's very common in Tableau, in Power BI, in many platforms. Actually, it's even common in old GoodData, let's be honest. And we should stop accept it, and we should upgrade our stacks so this problem no longer exists. And it's not only about performance, but it's also about money, as always. Yeah. So once you realize that you pay like thousands of dollars for your Snowflake just because BI tool is used by hundreds of people and they are using quite simple things there, but still every action in BI tool means SQL query in Snowflake, and they are using it 24/7, so Snowflake cannot hibernate. And at the end of the month, you realize that you don't have enough money to pay your Snowflake bills. Yeah, so this is how we fail. By the way, please raise your hands who is satisfied with the performance of his or her BI tool. Okay, just GoodData hands raised. That's cheating, yeah. So this is exactly what I already described. Yeah, we all failed, and not only in the area of performance and cost, but also in the area of developer experience. Yeah, imagine that you maintain the whole data stack as code through APIs or SDKs in the world of Microsoft, yeah, or in the world of Tableau, yeah. No way, yeah. So what we expect here are APIs and SDKs, as code approach, and some kind of CI/CD, be able to test everything, version everything, as Maddie already mentioned, and so on. So here is just short story of GoodData. Let's make it brief. So there are basically two GoodDatas. Yeah. The first one, we still have many customers running GoodData 1.0. This is end-to-end solution, including data pipeline, very legacy. We developed everything in-house, and customers have to move their data to our premise. GoodData 2.0, we started like 4 or 5 years ago, building new GoodData on Greenfield. The main difference, you can run it on top of your data warehouse like MotherDuck or Snowflake. You do not have to move your data. And the developer experience is much better. And the stack is basically more modern and more open. But is it enough? Is it enough to run GoodData on top of, let's say, Snowflake or MotherDuck? The problem is that the traditional data warehouse technologies do not provide low enough latency, high enough concurrency for reasonable cost. So even with new GoodData running on top of Snowflake, let's say, it's still not good enough. Yeah, maybe much better with MotherDuck pricing, but still, if you need very low latency and you have to connect MotherDuck running even in different AWS region, I think it can be better. And that's why we developed something what we call Analytics Lake. That's just a buzzword. Yeah. So please don't take it that serious. But what is the concept? Yeah. What is it about? Yeah. So the Analytics Lake consists of two parts. Yeah. The first part is responsible for all the physical executions, while the other part is responsible for something we call semantic layer. Why we need semantic layer? Because the physical data model is not enough. There is not enough semantic information about the data. Yeah, you don't know. So first of all, most of data models are, how to say it politely, it's a mess. Yeah, so there are tables like T1, T2, and T3. Yeah. There are columns like revenue 1, revenue 2, and revenue 3. That's quite common. Yeah. So that's why you need to describe the data with more properties. You need to provide some good description of what is stored in the database. And once you have it, you can generate much better requests for the physical execution, which is typically SQL, but can be also something else. And in the physical part of the Analytics Lake, we built something what we call FlexQuery engine, which is actually GoodData agnostic. So we are even thinking about to open source it, but it's quite expensive to open source something and maintain the community. But I would like to do it right now. Yeah, and we use open technologies in this platform. There is nothing proprietary there. Specifically, we use Apache Arrow and Apache Arrow Flight framework, which is very efficient for in-memory processing and for data exchange across the network. As an execution engine, we use, what a coincidence, DuckDB. And with this framework, you can very easily, and that's about the developer velocity and developer experience, you can very easily build new data services on top of this stack. So you can get the data, process the data with DuckDB, and then you can do whatever you want. You can use like pandas or polars or whatever else. And you can implement use cases like pivoting or machine learning or whatever. Yeah. And you implement just the logic you want to implement, and the rest is provided by the framework. Okay, so this is I like the diagrams, architecture diagrams. Yeah, so this is the architecture diagram of the Analytics Lake, or respectively the whole analytical platform, GoodData. You can see Analytics Lake responsible for the semantic layer and SQL generation, and then the FlexQuery responsible for the physical executions connected to data sources like Snowflake or MotherDuck, caching the data in a specialized cache, and post-processing the data in any way. And in the future, we would like to allow our customers even to embed their custom modules. That should be definitely feasible and easy because they can utilize the framework. Okay. I'm quite fast, so we will have more time for something real. So let me present you a real user, respectively developer experience, actually powered by DuckDB, running on top of MotherDuck. Yeah. So first of all, I have a lot of demos here, so I will context switch between the presentation and the demos. And please stop me if I'm running out of the time, Jessica. Yeah? So first of all, you need to get the data to your BI tool. Yeah, you need to crawl the data from multiple sources. You need to transform the data. And usually you need to create something like stars or Snowflake schema, clean up the data so they are like valid connections, valid primary keys. So then you can allow your business users to work with these clean data safely. Yeah. So for that, I prepared something what I call data pipeline blueprint. It's actually open source repository, and the link will be in the end of this presentation in a form of QR code. And in this open source repository, I'm demonstrating several approaches. First of all, let's say following best engineering practices. That's really important if you want to build something what will survive years and it's maintainable. Yeah. So every definition of extract, load, transform, and the analytics, every definition is as code stored in version control system like Git. And everything is running in multiple environments like dev, staging, and production. And everything in my case is orchestrated by GitHub Actions. But you can use any other orchestration tool like Airflow, Dexter, whatever. I would like to extend it with something like that, but you know, there are different priorities. Yeah. Currently, this end-to-end data pipeline, like until 2 weeks ago, it was running only on top of Snowflake. But now it's also running on top of MotherDuck, especially because one of the latest releases of MotherDuck, when they started supporting backward compatibility for drivers. So now I can keep the same driver in the pipeline and run it forever. I don't need to release new driver every 2 weeks. That's really important. I'm crawling data from GitHub API, from AWS S3, and from Jira API. I'm storing these data to Snowflake or MotherDuck, one-to-one to tables with JSON columns. And I'm using Meltano tool for that because it's extremely versatile, meaning you can easily exchange any extractor and any loader. You can combine them freely because there is a framework in between. Yeah, so you can change Snowflake to MotherDuck with one line of code in YAML. That's all you need to do. Yeah, it's really good. Then I transform data with dbt. Again, there is dbt plugin for MotherDuck, dbt plugin for Meltano. Everything is already prepared by the community. And once the clean output stage model is created, I generate GoodData semantic layer from it because we have GoodData dbt plugin, and deliver all analytical artifacts with our SDK to GoodData into multiple environments. Yeah? Meaning in GitHub, before merging any changes of this pipeline, everything is running against dev environment, after merge, against staging, where like business users could test it. And once it's merged into production branch, it's delivered to production. And there are also many applications running on top of GoodData, and they are stored in the same repository. So you can deliver change, like imagine that GitHub changes API, and I need to change some column. So first of all, I need to change how I call GitHub API. Then I need to change column names in many tables, and then I need to change semantic layer in GoodData, and then I need to change all dashboards, everything basically. Yeah, I can do it in one pull request consistently, so everything will work after I merge it. That's really powerful. Yeah, there is a link, so let's try it if my internet works. So this is the repository. There is quite comprehensive README with the same picture actually. And here, yeah, I have to look here because, so here is the last actually scheduled run of the pipeline. Because it's not only running when I'm merging something to the repository, but it's also scheduled every day or every hour, whatever, to run on top of staging as well as on top of production. And you can see like 5 jobs, Meltano jobs for 5 different data sets, DBT and GoodData parts, and all these parts are running against Snowflake with DBT core, against Snowflake with DBT cloud, and against MotherDuck. Okay, so let's get back. So the next user experience I would like to show you is standard GoodData. That's boring, yeah. So let's be brief. Okay. This panel is okay. So this is actually the development environment. You can see multiple workspaces. We call it workspaces for different data products. And also I am splitting workspaces based on top of which database they are running. So let's use the workspace MotherDuck, which is running on top of MotherDuck. This is GitHub overview. This is actually data are crawled from our open source repositories, multiple open source repositories. I am not a top contributor, actually, unfortunately. I am not developing enough, and you know. And then there is second dashboard, which is called Girocracy. We really like it in GoodData, this term, because Jira is evil, right? And because it's running on top of semantic layer with a clean semantic model, we don't have to be that afraid to let business users play with that. Yeah. So business users can edit dashboard. They can create a new visualization like here. And they can, like, I don't know what, yeah, calculate number of Jira tickets by when they were created, and they can filter it, like, I don't know, to last year, last 12 months is better, and by month, and create column chart and compare it with the previous year and name it like Jacek and save it, yeah. And save the dashboard. Did I do it? Yeah, I did it. Yeah, actually, this visualization is now different. Why? Because there is dashboard filter. Yeah, dashboarding is really complicated. Yeah. But I could overload it and let the whole history to be seen, no matter what dashboard filter is set. Yeah, this is creepy. I mean, like, dashboarding is really creepy. So, and as you could see, it was really fast. I created a new visualization, meaning I had to contact MotherDuck and calculate the query. and it was like almost instant, yeah, even though it's running on the other side of the world in US East. Yeah. Okay, so let's continue with something more custom, yeah, because many companies do not want our UI, yeah, because I don't know why. Maybe it's ugly, I don't know. But more often, they need something custom because they need to embed the data into their business applications. Yeah, they have, I don't know, let's say you are in a bank and you are responsible for loans. Yeah, and you need data to decide if you can approve or not approve the loan. Yeah, and there is some custom application written in JavaScript 20 years ago, and you need to embed this data as easy as possible. Yeah. So that's actually possible with our SDK, the JavaScript SDK, specifically React SDK, but we support also other frameworks. And you can embed like, so let me show the application if it works still. I don't know if it works still, but it seems that yes. Okay, so first of all, you can embed, it's slow because my computer is slow and not because the backend is slow. So first of all, you can embed the whole dashboard into any application you want. Yeah, that's easy. But you can also embed single visualization, or you can embed even raw data like a table, or you can easily build your own visualization. This visualization actually doesn't exist in GoodData. I built it alone, even though I am not a JavaScript developer. This is quite small actually, so you don't see it most likely. But this part of code is everything you need to do to build a custom visualization. Yeah. Let me just show you. So these data are from Federal Administration Aviation from United States about all flights in the United States. So let me change from N2 and store it, and we should see different visualization in a while after it's compiled. Yes, it works. So instead of FAA regions, we now analyze from which aircraft manufacturer are which. Yeah, so we are analyzing number of flights by manufacturer like Boeing and by the region in the United States, like Southwest. Yeah, so you can see that most of flights are managed by Boeing and in Southwest. Okay, so that was quite, it was still quite standard. So let's make it even more creepy. Yeah, so what you can do with our JavaScript SDK. Circa 2 years ago, we attended a hackathon here in GoodData. And because I am not a JavaScript developer, as I have already mentioned, so I invited my colleague, Dan Homala, who is expert JavaScript developer. And together we try to build a data visualization in virtual reality. So this is a picture. It's actually running. It's delivered from the same pipeline to render.com free offering. And as you can see, hopefully, yeah, it still works. So as you can see, you can explore data in 3 dimensions with virtual reality headset. The code is open source. The application is public. Feel free to open it in your virtual headset. It's very different from when you see it here. I mean, like you can walk physically. through the data. You can even fly with thumbsticks. It's quite interesting and completely different way how to view the data. Okay, but as I mentioned, I'm not a JavaScript fan, but I'm more Python fan, actually. Yeah, because we build a lot of things in Python. That's the second language in our platform. And that's a language which is very often used for data analysis. But doing something like that locally with CSV files, well, it doesn't perform that well, and you don't have the semantic layer, the same source of truth like your JavaScript developers or any other consumers. Yeah. So we provide Python SDK connected to our APIs. So you use the same semantic layer, same caching, same everything. But instead of JavaScript, you use Python, for example, here in Jupyter Notebook. Yeah. This is, yeah, so this is the notebook, and hopefully it will do something. Yeah. So first of all, you can like just list objects in our semantic layer, like metrics. Yeah. But you can also calculate a report like this. And you can calculate the report from already stored visualization, or you can build on the fly your custom definition of the report. In this case, calculating count of commits and count of pull requests per month and per repository. And then once you have the result in data frame, because result is a data frame, you can use, for example, some machine learning libraries, calculate something like predictions, store them back to the database, map them to the semantic layer, and the whole circle is closed, and you can iterate as you want. Yeah. On top of the same source of truth. And the last live demo, so far we were talking about running something on top of MotherDuck. Now we are going to talk about running something on top of pure DuckDB. The FlexQuery, as I have already mentioned, the engine responsible for physical execution, is powered by DuckDB. I decided to build a demo for data federation. So what you can see here, you can see a Streamlit application connected with Python SDK to our GoodData server. You can see Streamlit application connected directly to the FlexQuery engine, not GoodData. Yeah. FlexQuery engine exposes Aeroflight RPC and provides libraries for connecting to FlexQuery and executing anything you want. And one such use case, which I demonstrate here, is the federation. So in my case, and yeah, I forgot to describe what is here. Does anyone know what is here? What's this query? Exactly. And number? I think it's 4. So to demonstrate the power of FlexQuery, I decided to store, there are 2 tables here, orders and line item. These are the biggest table in the benchmark, actually. So to make it complicated, I decided to put the smaller table to AWS S3 and the big table to Snowflake, respectively to Postgres. Postgres is running locally, Snowflake is in EU Central 1, I think, region. And the FlexQuery is responsible for crawling data from Snowflake or Postgres, crawling data from AWS S3, store them as Arrow tables in FlexCache engine, and then open DuckDB process and execute exactly this query, but not on top of the DuckDB, but on top of the Arrow tables. Yeah, because you can map Arrow tables into DuckDB process seamlessly, absolutely seamlessly. And this is the result, the Streamlit application. And to make it more interesting, I make it a little bit interactive. So what you can do here is you can change the cache key and bypass all the caching. Yeah, now it's running against local Postgres and AWS S3. In 6 seconds, you crunch like gigabytes of data from 2 different sources with DuckDB, including remote connection to Postgres, remote connection to AWS S3. But what if I change the aggregation column? So what happened now? No Postgres was contacted. No AWS S3 was contacted. And instead, the caches were reused because all columns are already there and everything was calculated only by DuckDB, and it was much, much faster. Yeah, I can also change the filter, and it's again running much faster than before. And then I can rerun the same query, and as you can see, this is exact cache hit, so no DuckDB is involved at all. Just GoodData caching is utilized, and the response time is like 10, 20 milliseconds max. Yeah. And yeah, I forgot to change it to Snowflake. Let's make it interesting. Will it work? Hey, it's still cached. Now it's not cached. So how long it will take? What do you think? The same time, actually. That's interesting. Yeah. And that's the difference between row-based database, Postgres, and column-based database, Snowflake. Yeah. So they are, the duration is the same, but the difference is that Snowflake is not on my laptop, but in the AWS. Yeah. Okay. So am I running out of the time? Cool. So last slide, just marketing, yeah, but developer marketing, yeah. Coming soon, yeah. What actually I am currently working on is AI, obviously, but we are trying to be serious here, yeah. So we are going to utilize our semantic layer, directly competing to all text to SQL solutions, which they are currently on the market. There are many, many, many such. Even Snowflake invests enormous effort to build text to SQL. We think it's not a good way. The good way is to utilize the semantic layer containing much more context, and to do it in a serious way, in production quality. We would like to introduce specific new services inside our platform, and they will be basically responsible for the RAG architecture. Yeah? So there will be vector database. We will search semantic layer. We get only relevant context relevant to the user question, and we send it to LLM. So the answer is more accurate, it's faster, and it's much cheaper, yeah, because you pay for per token, yeah, in OpenAI, for example. So this is currently what we are working on, and we should release it in Q3, actually. At least our chief of product says it. Okay, so this is just a quick recap. So truly responsive analytics means semantic layer, DuckDB, MotherDuck, and the FlexQuery. And why does it work? Because we use state-of-the-art technologies like DuckDB, which is really state-of-the-art. We are laser focused on analytics. We don't use one database for all. We don't use DB clusters because it's no longer necessary, like Mehdi described in his presentation. And also because the competitive pricing, actually, yeah. I really recommend you to go to MotherDuck pricing and compare it with Snowflake pricing. And what's next? In our partnership with MotherDuck and DuckDB, I would like to explore the area of multi-tenancy because that's our differentiator, GoodData differentiator. We can serve customers like Visa with thousands of workspaces, and deliver something like that in large scale is really complicated. And MotherDuck is going to release features related to multi-tenancy as well. So my idea is to build end-to-end multi-tenancy in the whole data pipeline. And that's all.